Hello, so next topic is Bitwise Left Shift. How Bitwise Left Shift work? Very easy. So it is represented by uh, greater than less than two times, or you can call it arrow, left side arrow. Okay, so this is how you represent left shift operator. If I write a simple question here, uh, tan is left shifted by 2. Tan is left shifted by 2. What will be the output? To understand this, we have to calculate the binary of 10 and binary of 2. Okay, to calculate the binary, we already know how to calculate the binary. Let me print this. Okay, so binary of 10 will be 1, 0, 1, 0. Simple. So this is the binary of 1, 0, 1, 0. That is 10. And what will be the binary of 2? So it will be 1, 0. Okay, because in this series 2 will come after adding only 2 itself, so this will be 0. So let's put 00, 10. So now you want to shift it by 2, so you don't need to calculate the binary of 2 here. How it will work? 10 is left shifted by 2. You have to put this binary in a 8-bit slot format. So these are 4 bits. We will put it in 8-bit format. So put as many as zeros as you need to complete a 8-bit slot. This is a 8-bit slot. Okay. Now you have to shift it towards left. How to do it? You have to shift each and every bit to the left. So this 0 will be shifted here. This 1 will be shifted here. This 0 will be shifted here. Okay, everything will shift to the left side. Whatever will drop from here will come back here. Correct? So this is how it works. Now, when you shift it for the first time, this first 0 will be will come back here. Okay, so everything will be shifted left, shift towards left. So there will be 3 zeros. This 1 will be shifted here. Correct? This 0 will be shifted here towards left. This 1 will be shifted here. Again, this 0 will be shifted here. Now what we put here, we will put here the bit that you removed from the left side. So 0 was removed, so 0 will be here. So this is what the bits will look like when you shift it for once. Now how many times we have to shift it? We have to shift it 2 times. How can we do that? Now shift it twice. For the second time, there will be 0. This 1 will be shifted here. This 0 will be shifted left side, like here. 1 will be shifted here. This 0 will be shifted here, and this 0 will be shifted here. This 0 will again come up here. So this is the final output when you shift tan twice, 2 times, or you shift tan by 2. Tan is left shifted by 2. Okay. Now put this particular binary into your list. So there are how many zeros? 3 zeros. So we will put 0 here, 0 here, 0 here. 101. So 1 will be here, 0 will be here, 1 will be here. Okay, and that's it. 101, 000. 00 will not count because this will not gonna add any value to it. So okay, now add those values where you find 1. So 32 plus 8, it will be 40. Correct? So this is the binary of 40, and the output for this will be 40. Correct? This is how it works. You have to shift all the bits towards left. Let's take one more example. So if I take, for example, 24, 24 is left shifted by 3, for example, or 1. You can try as many as questions you want. So what will be the binary of 24? Binary of 24 will be 11 1 0 0 0. 16 plus 8 will be 24. So 11 1 0 0 is the binary of 24. 11 1 0 0 0. Okay. Now we have to make this an 8-bit slot. Again, the question arises, if the bit slot or the numbers binary is contains more than 8 bits, so we will go for 16 bits. Okay. So we have to work on 16-bit architecture. So here the numbers binary is not more than 5 bits. So let me cover it and make it a 8-bit slot. That's it. This is my 8-bit slot. Now I have to uh, shift all the numbers toward left 3 times. So as we all know, for the first time, this 0 will remove here and will be added in the last, again and again for the 3 times. So these all 3 zeros will come up here. So if we shift it 3 times, the output will look like this. All the bits will be shifted here. All 3 zeros will be here. Correct? So this is the binary of after shifting 24 left side. So let me we have 6 zeros. Okay, 1 2 3 4 5 6, and this ones will be here. So 128 64 11 000 000. All will be 0 here. This will be 0, this will be 0 0. So now add these two numbers. Okay, so this will be 180 190 192. So 192 should be the output. Correct? So this is how you shift bits towards left. So this is kind of adding operation, as system do not know how to do math. It only knows how to work on bits. You give the input in any language, and it will convert it into binary. Once it is converted into binary, it will process it and understand what you are trying to say. So these bitwise operators are for the systems. Okay, so or for the lower level coding, chip coding you can say. So this is how it works. Let's move to the right shift.